All right, blood stoppage. You know, how do you stop a bleed, if you will? Uh, Let me back up here. Let's just say. All right, there you go. Yeah. So vascular spasm is going to be one of it, and that's this vasoconstriction. Then you'll get the platelet plug form. That's just like it sounds. And then you'll actually have the blood clotting itself, which is an extremely complex mechanism, which we'll try to go through. You know, so the spasming, when you damage the tissue and the blood rushes out, that kind of stretches the smooth muscle. Think of it like that. And when you do that, smooth muscle responds by constricting. There's also pain, which will cause the muscles to constrict, and then certain chemicals released by the cells when they are damaged, which will cause the smooth muscle in the artery or vein, arterial or venual, to constrict. That's this spasming. And then that should kind of clamp down the diameter of the lumen of the vessel, and that should slow the blood flow, right? Next is the actual clotting itself. So what's going to happen here? The platelets will show up, and they have this platelet factor 3, or this tissue factor, which is produced by these cells. They then will trigger, when they get released in the right amount, will trigger this factor 10. That's not X, factor 10. That factor 10, then it's a protein, and it just turns from one form to another, and it acts as an enzyme then to like convert the prothrombin into thrombin. And then that thrombin acts as an enzyme to convert the fibrinogen into the fibrin. And then the fibrin is the actual protein there that is going to be, what happened there? Let's go back. That's going to be acting like a net, like a fishing net, if you will, to trap and hold platelets and other things to actually form the plug. So when the inner lining of the vessel is damaged, it'll release serotonin. And that serotonin and such, it's also released by the platelets. That causes and tells the middle layer, the tunica media, which is smooth muscle, to constrict. When this happens, when these things are happening, the platelets then become very sticky, and they will stick to this area of this damage. Now, these smooth muscle cells, which are constricting, are turning ATP into ADP. That also enhances the platelets to come to that area and to stick and such. While this is taking place, they will release this prostacyclin, which prevents the platelets from getting sticky and sticking out of the place. It just focuses on that one area, you know. So now you got the platelets kind of sticking in there and trying to hopefully stopping that damage, that leak in the endothelium. The endothelium is the inner lining, it's the tunica intima of the blood vessel and such. Now you're going to have the blood actually form the clot, this coagulation and such. There's chemicals which prevent that, and there's chemicals which promote that. And then there's a couple of pathways, an intrinsic and an extrinsic. The intrinsic is when there is a damage. It's kind of like an internal damage and all of that. Do you really need to clot the blood? It's a multiple stepped, 1 through 13 steps and such, and it gives more scrutiny. The extrinsic is the damage is like from outside. So you really have to get this clot stopped, or this bleed stopped. And so you don't have this time to go through all of these multiple steps. And so you jump right to this step 10, and then boom, you get a rapid response. A clot formed very quickly. You can see that 10 to 15 seconds, very quickly and all. If you've ever poked your finger with a needle, how quickly does the blood stop flowing? Pretty quick. Like I said, it's a multiple pathway, and I don't expect you to know all of these different enzymes and different factors and all these different steps. I don't expect that from you. What I want you to look at it right there, though, it requires calcium. And these chemicals and such, these clotting factors are produced in the liver, and you have to have calcium for this as well. And there's a vitamin needed to help in the absorption of calcium, and there's a vitamin needed to form these clotting factors. So one vitamin is for calcium absorption, one vitamin is for the production of the clotting factors. I'll let you figure that out. But you can see right there that it does require you go through this activation as factor 10, a common pathway, which then, and it's not the 1, 2, 3, 4, 5. It's when were they discovered. That's how they name things and such. So along this, these clotting factors, factor 10 was discovered after factor 1 was discovered and such, if you will. So, but it goes through this pathway, and then every little step, it's an enzymatically controlled pathway, if you think of it like that, until you finally get to this prothrombin, which then changes shape and becomes thrombin. That then causes, that acts as an enzyme, and it takes the fibrinogen and it converts it into fibrin. And then the fibrin with the calcium, got to have calcium and such, stabilizes it, and then you get the actual net, which will then like form the clot and stop the blood flow and all. Once that's formed, you don't want clots hanging out. You don't want them traveling around. You want them to do their job and then go away. So you need a way to shrink the clot, and then you need a way to get rid of the clot and all. So that actinomycin actually causes this contraction of the clot and such, the platelets and such, and then it'll kind of shrink or pull up, and kind of when you see a scab forming, this is what we're kind of referring to. But this will happen internally inside the vessels as well. There is a growth factor that the platelets will release, and this is this platelet-derived growth factor. You can see that, and it stimulates fibroblast, which is in the connective tissue, to move into that area and to start the repair, start mending the torn vessel, the cut vessel, and such. But that's that PDGF. So now getting rid of the clot, like I was kind of bumbling around about there. You have this TPA, and that causes this plasminogen to be activated, and that means it turns from plasminogen into plasmin. And then the plasmin is actually a type of enzyme which slowly breaks the clot down. No, that's its job right there, this clot eradication. What limits clotting? Of course, your blood travels so fast through your body, it should not clot. When blood slows down, blood will clot. Other things which will interfere in, and you can see right there the prothrombin 3, protein C, and heparin, and all those things which will then prevent clotting. The heparin actually keeps platelets from sticking to a injured site, which prevents clotting. So you can have bleeding disorders, and you can read through those right there. But you notice there an impaired liver function, right? So you're actually not making the procoagulants, the clotting factors. You need vitamin K. Well, I told you had to look for it. Look at there, you found it. And you need that vitamin K, which is essential for clotting factors. Don't go out and take a bunch of vitamin K. The bacteria in your gut produce the vitamin K for you. You want to have enough vitamin K? Be nice to your gut. Other disorders and such, thromboembolic disorders, undesirable clotting. You don't want clots. A thrombus, of course, is a clot in the vessel. An embolus is a gas bubble in the vessels and such. So you have these chemicals that can dissolve the clot. Aspirin will actually help inhibit the thromboxane, which is one of those clotting factors and such. You stop that in the pathway and you don't get the clot formation. Heparin is one, and then dicumarol is an anticoagulant because it actually blocks vitamin K. No vitamin K, no clotting. There are genetic disorders, and they've run these down to what's actually missing in the individual. You can see the hemophilia A is a defective factor 8. Hemophilia B is a defective factor 9. So they actually produce genetically engineered TPA and factor 8, and so you don't have to transfuse. You still have to transfuse, just not as often. When you transfuse, you need to know your blood type and such. We're going to get to that blood typing. So transfusion, you can do the whole cells, everything, red blood cells, plasma, everything, or you can just transfuse the red blood cells. You take your donated blood, you spin it in a big centrifuge, you pack it down, you just give the red blood cells. So, all right, we're going to stop right there.